Okay, let's start our journey into counting. And I just want to take a minute to say that counting is hard. Some parts of it are pretty easy and straightforward, but as we layer it on, it can become quite difficult quickly. But first, we want to just address some basic ideas of counting. And when we're facing a counting problem, we often have to decide, are we completing steps, or are we making choices? So the steps are when I do maybe step 1 and then step 2 and then step 3. So it's an and. Whereas choices, it's one or, and it's an exclusive or, 2, or something else. But these is an exclusive or. So like I stay outside or I go inside. So those can't happen at the same time. So let's see how they can maybe appear in a problem. Let's say we have our shapes, our character, our objects up here. So we have 4 distinct letters, 4 distinct digits, and 3 distinct shapes. And I want us to create a password that has the first two characters will be letters, and you cannot repeat. No repetition, which we'll talk about more in another video about repetition. Then you have, the next one is, all right, so the third character is a digit. And the fourth character is a shape. All right, so let's kind of illustrate with a tree how this might look. So step 1 is going to be to choose. So within this step, we have a choice to make. And we have to choose A or B or C or D and not both of anything or more than one of them. So I'm going to write down our choices. And if I wanted to say how many choices, you would just add them up, right? 1, 2, 3, 4. So I have 4 choices in step 1. Step 2, I choose the next letter, and I can't use one that I used before. So if I chose A, then I now have 3 choices here, B, C, and D. If I chose B, then I now have A, C, D. If I had chosen C, I have A, B, D. And as you can imagine, here I would have A, B, C. So in step 2, I had choices to make. And so let's say I'm at this, I've chosen A in step 1. So step 2, I have a choice between 3 distinct objects, B, C, or D. If I had chosen B, then I have a choice between A, C, and D. So then step 3 is to choose a digit. And for each one of those, I have 4 choices. I don't want to write them all out because it's going to get crowded. So it could be a 1 of, what are my digits? 1, 4, 5, or 7. And we have this little pink 4 brancher coming out of every single one of these. We'd have it here as well. And so on, all the way down. And then lastly, in step 4, whatever I chose in the step 3, and by the way, I had 4 choices, I just add them up, I would have just 2. So each one of those comes off with 2, 2, 2. And so let's just see what we have at every iteration. So at step 1, I had 4 choices. And then step 2, so then I complete the next step. And for each one of those, I have 3. So the way we count that is we multiply, right? So for every one, I have 3, and I have 4 of them. So I should have 4 times 3 of them, or 12. And then in step 3, for every one that I had above, so A and then B, or A and then C, A and then D, I have 4 coming off of there. So for every one that I got from step 1 and step 2, which we agreed was 12, I have 3 more choices. So that's going to be times 3, 4. 4 in this case. Step 3, but 4 choices. And then lastly, for every choice I've made up to this point, so let's say I'm right here, which means I chose A and then B and then 1, I now have 2 choices. And that's true for every possible arrangement we have before. So times 2. So the moral is, when you have choices, and that's an exclusive OR, we add, right? We had 4 choices here, A, B, C, or D. We just added them up. And if we have steps, we multiply. And we will see that often in counting. When we approach a counting problem, we'll often break it up into the steps. What do we do first, and then what, and then what? And within the steps, we often have choices.